Hello, everyone. In this video, we are going to look at example 2 in section 4.4. So I really encourage you to take a look at this example on your own before watching the video. And then when you're ready, continue to check your work. All right, so in all of these parts of example 2, we want to find the antiderivatives of the given function. So recall, that means what? So that means we need to find a function f such that f prime is equal to the little f given. So we want to find what function has a derivative of the little f given. So some of these we're just going to have to trial and error. We're going to have to guess and check some. The more of these you do, the more comfortable you will be with spotting them out. One thing that we're going to rely on a lot are using functions for antiderivatives that have powers. Because recall, when we have a function such as x to the n, the derivative with respect to x looks like n x to the n minus 1. So whenever we have a function where we want to take the antiderivative that has a power, then we can think about how we have to undo that power in order to get back to the original function. And we'll see this a little bit in the summary table below. But this is just to get us thinking. All right, so let's think together. So a function whose derivative is 3x squared. Well, if we started with a function f of x equals x cubed, could that be an antiderivative of 3x squared? Yeah, well, let's check. So how we check is compute the derivative of x cubed. So the 3 comes down, and we subtract 1 from the exponent. So yep, that works. Similarly, we can see that an antiderivative of 4x cubed should be x to the 4th. But let's go ahead and check. So here, x to the 4th, let's take the derivative. 4 comes down, subtract 1 from that exponent. Yep, it works. What about for cosine x? So recall, sine and cosine, when we take the derivatives, they have a nice relationship. Meaning if we have sine of x, take the derivative, we get what? We get cosine x. And when we have cosine x, take the derivative, we get negative sine of x. So we can keep taking derivatives of sine and cosine, and we go back and forth. And do we see the antiderivative of cosine here? Yes, we do. It's sine. So if big F is equal to sine of x, well, the derivative of sine of x is that cosine of x, which is the function that we want to find an antiderivative of. All right, so what about d, x squared? So this means we want a function, when we take the derivative, we're left with x squared. So as we saw with the previous power functions, if I had a 3 in the exponent, then when I went to take the derivative, what happens? F prime of x, the 3 comes down, and now I have a 2 in that exponent, which is what I want. But I also get this 3 constant being multiplied by the x squared, which I don't want. So how do we remove that? Well, if I was able to multiply by 1/3 or divide by 3, that 3 would cancel. Well, here is something interesting, is if I multiplied my original function by a constant, when I take the derivative, that constant just remains. So let's test then the function x cubed over 3. That is x cubed times that 1/3. So let's consider the derivative of this function. So now x cubed in the numerator, so we use the power rule to get 3x squared, and then we're still dividing by 3 because that 3 is just a constant. And that 3 cancels out to give us the function x squared. So our antiderivative here will be x cubed over 3. So I'm going to go ahead and clean some of this up so we have enough room. So my function should be f of x equals x cubed over 3. So what about this next one? It's similar. We have a cube in the derivative, or rather we want to find the antiderivative of x cubed. Well, we could do something similar to what we just saw. So if I had a 4 in the exponent, then when I take a derivative, that 4 would become a 3 when I subtract 1 from the exponent. But I'm going to have, rather, when I take that derivative, an extra 4 that comes down. So to get rid of that, I'm going to divide by 4 in the original function. So let's go ahead and check to see if this is an antiderivative. So x to the 4th over 4. Take the derivative, so the 4 comes down, we get x cubed, and we divide by 4. The 4's cancel, and we're just left with x cubed. Awesome. All right, what about this next one? I'm going to clean up a little bit here so we have room. Now we're looking at x to the 4. So notice we start with x squared, found an antiderivative to be x cubed over 3. For x cubed, an antiderivative was x4 over 4. So what about for x4? Awesome, good guess. Let's try f of x, antiderivative being x to the 5th over 5. Let's do our check. So here we're looking at the derivative of x to the 5th over 5. So the 5 comes down. We subtract 1 from the exponent. Divide by 5, the 5's cancel, and we're left with x to the 4. So check, we found an antiderivative. All right, so similar to computing derivatives, if we compute a derivative of a sum or difference, we just need the derivatives of each part. Very similar story for finding antiderivatives. So if we want to find an antiderivative of this distance, we need an antiderivative of each part. So notice to get a squared term, we need a x cubed. But we want a 5 out here. So if we just multiplied by 5, that would be a good start. But when we take the exponent, or the power, the 3 will come down and multiply by that 5. So I want to delete that in the end. Oops, that should have been a 3 here. I want to cancel that when the derivative happens. So I want a 3 to be divided in my original function then. So the first term we're going to use is 5x cubed minus 3. And similar with the next term, I want a 2, and I need a 3 in the exponent, so I'm going to put a 4 in the antiderivative. But then I'm going to divide by 4, so when that power comes down, I don't get an extra 4 there. So let's check the function antiderivative 5x cubed over 3 minus 2x fourth over 4. So to check, we want to compute the derivative of this function. 5x cubed over 3 minus 2x to the 4th over 4. I'm going to compute the derivative, which means I take the derivative of each term. So here we go. 5 times 3x squared, using the power rule, divide by 3, minus 2 times 4x cubed over 4. 3's cancel, 4's cancel, and what are we left with? We're left with, do a little more cleaning, we're left with 5x squared minus 2x cubed. Was that the original function we started with? Looks like it. So we found that our antiderivative of 5x squared minus 2x cubed is 5x cubed over 3 minus 2x to the 4th over 4. All right, so in the next video, we're going to fill in this table of antiderivatives for some common functions that you will see throughout this class.